Okay, so in the last video, we looked at Newton's first and third law. Now let's look at Newton's second law, okay? This is what I like to call the mathematical law. Okay, and the reason why is because this is the one that leads directly to essentially the rest of this unit where we focus on applications of law. It's going to sit around this second law. Okay, so the first law focuses on when the forces are balanced. So again, remember the first law we call also the law of equilibrium. But the main thing is objects are going to be at rest or they're going to move with constant velocity, which means all the forces that are acting on the object are balanced. The next thing, right? So Newton's second law is now going to focus on what happens when those forces become unbalanced, right? So if there's an unbalancing the forces, something happens. Okay, so if there is now a net force on the object, the velocity of the object will change. And what does that mean? Well, the object is going to accelerate. Okay, and it's going to accelerate in the direction of the net force. Okay, so if the net force is to the right, the object will accelerate to the right. If the net force is to the left, it will accelerate to the left. Now, that doesn't necessarily show us how the velocity changes, but you have to know the direction of motion to determine, are we changing the velocity by speeding it up, or are we changing the velocity by slowing it down? Now, in general, we say that a net force is what causes an acceleration, okay? So it's not necessarily a force causing an acceleration, but a net force causes an acceleration, right? That's the key. It's the net force that causes it. So all the forces that are acting on an object, one area becomes unbalanced, and then it's going to accelerate in that direction. So here's the actual law. So basically, the second law will redefine acceleration. So it states that acceleration is directly proportional to the force of acting on an object and inversely proportional to the mass of the object. So by definition, what they're saying is that acceleration is directly proportional to the force and inversely proportional to the mass, right? And so we say that A is directly proportional to F net, and A is inversely proportional to 1 over m, okay? Now, again, I said that this was Newton's mathematical law because you can see from the definition there, we have an equation. Oh, sorry. So the equation actually works out to, this is how Newton defined it, but really the redefinition, you see it written as the sum of the forces is equal to, and again, these are going to be vectors, right? So the sum of the forces is equal to mass times acceleration, okay? And in this picture, so if this box is originally sitting still and this boy pushes this to the right, right? Because the push will now unbalance the forces that are acting on it, the object will accelerate to the right. Okay, remember, it accelerates in the direction of the net force. And so let's look at I wrote over top, but a quote-unquote easy example, okay? So estimate the net force needed to accelerate a 1,000 kilogram car at half a G, and B, a 200-gram apple at the same rate, okay? So first of all, 1/2 G doesn't necessarily give us our acceleration, but what we need to do is plug in what G is. So it's going to be 1/2 of 9.8, which is 4.9 meters per second squared. So this is what we're accelerating the 1,000 kilogram car and the 200-gram apple. Okay, so I'm going to say F equals ma. And so this is going to be 1,000 times 4.9, which gives us 4,900 newtons. Okay. And you can see why this is, I'm calling this is an easy example, because we're just basically, multiplying. And now we're going to do it the same thing with our apple. Now, you do have to be careful with the apple. This is in grams. We want this in kilograms. So we're going to move our decimal point 3 to the left. So we're going to multiply 0.200 times 4.9. And we get an answer of, sorry, I have my notes over here all worked out, 0.98 newtons, okay? So one thing to note, I didn't point this out, newtons is the SI unit for force, right? And we abbreviate it capital N, and yes, named after Sir Isaac Newton. So that's just an easy example. Let's look at a little bit harder of an example. The reason why this is harder is because this brings in stuff from unit 1 here in unit 2, right? Because in unit 1, we did talk about acceleration, right? And here in unit 2, we have redefined acceleration. So unit 1 focuses on the description, right? So like this is basically acceleration tells us how quick we change our velocity. Unit 2 is going to tell us now, how do we accelerate it? Okay, what are we doing to cause that acceleration? So here, what average net force is required to bring a 1,500 kilogram car to rest from a speed of 100 kilometers per hour within 55 meters? Sorry, 100 kilometers per hour. So first thing we need to do is we need to convert our kilometers per hour to meters per second. So 1 kilometer is 1,000 meters. 1 hour is 3,600 seconds. And so that's going to give us a initial velocity, right, of 27.8 meters per second. And then the next, we're going to now take our equation and we're going to use one of our motion equations, our cake equations. We're going to use the equation with no time, and we're going to solve this for acceleration. Okay, where we know sorry, I crossed out the wrong one. It's this one we're crossing out. And so we're going to do negative V0 squared over 2, not 2a delta x, but 2 delta x. And so this becomes negative 27.8 meters per second squared, right, over 2 times 55 meters. And that's going to give us an acceleration of negative 7.03 meters per second squared. Again, negative because we're stopping, right? Or negative acceleration because we're stopping. And then anytime when it says average, again, this is, remember, average just means whole trip. So we're looking for the whole trip in terms of its force. And so we're just going to say F equals ma. And so we're going to have a 1,500 kilogram car times negative 7.03 meters per second squared. And then we have a force of 11,000 newtons. Okay, the negative just means that it goes against, right? It goes against our motion. How do we know that? But because the object is coming to a stop. Okay, so every other video from here on out is now going to focus on the applications of Newton's laws.